Tuesday at 2 p.m. Is this the ROMKids Show? Hello everyone, nice to see you. Very excited to hang out with you this afternoon because we will be making our very own sugar crystal, a nice edible snack. That's why I'm wearing this apron. We have a very special guest, Veronica Di Cecco, on, returning. She did an awesome episode with us that's up on YouTube, all about meteorites and meteorons. Today we're going to dive into the world of crystals, minerals, and rocks, and all their uses. So I'm really excited to talk about that because like minerals and rocks and crystals and all of these things are used not only in like our makeup, which I put a little bit on right before the show just to get ready and fancy. They're not only used in our jewelry, but they're used in our everyday lives as well. So we're going to talk about that, make some nice edible science as well. Everyone, my name is Kieran. I run the kids camps at the Royal Ontario Museum. The ROMKids Show is our distance learning initiative. So if you are at home and doing this experiment with us in your kitchen, hello, 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 nice to see you. If we are in your virtual classroom or your your actual school, hello, hello, hello as well. And if you're watching this later on YouTube, hi friends, how's it going? Very excited to be with you today. All of our episodes are up on YouTube. Last week we had Courtney Murphin on talking about whales, which was really cool. So many different themes, choices, all amazing things to see up on YouTube. With that, I think we're ready to go. I think it is time to do the theme song portion of the event. Oh, also because it's Rocks and Minerals Day, I'm wearing my space socks, just so we know that. All right, here we go. Welcome to the ROMKids Show with me. We'll do some crafts and tell some stories. Let's talk about science, art, and history. Welcome to the ROMKids Show, starring you and me. Nice, there we go. That's the theme song portion of the event. Very, very cool. Let's move on over to our art table, where we have a lot of things to talk about, a lot of stuff to show. Went into the museum last week and took a bunch of stuff home with me, and we're gonna see all that stuff today. But what are we doing? We are making sugar crystals, okay? Look at that right there. This one was made by the amazing Alex Schneckenberger, who might be in the chat right now, I don't know, who's our assistant camp director. And she's right there. She made this beautiful crystal, and we're going to try and replicate that today. This is something that is easy to do at home. So what do you need? Okay? What do you need? You need 1 cup of boiled water. All right, so hot water. This is an activity to do definitely with adult supervision. So like, let's get that PSA up there right now. This is something that you're gonna wanna do with a trusted adult that you feel safe doing safe things with, okay? Next thing, you're gonna need 3 cups of sugar. Now, just so you know how much sugar that is, this is a bowl. This bowl is used every night in our household for popcorn, and we filled it up with sugar. So that's so much sugar. I can't even imagine it, but we're gonna use all of this today. What else? If you have food coloring or like any sort of flavor that you wanna add to your sugar crystal, you can grab that as well. You need a plate with sugar on it, and you're going to need some sort of like wood dowel or something. This is what, just like a little kebab thing. It has a real name, I can't remember. A skewer, or you can use like a popsicle stick or something like that. And then you're going to need a container to make your sugar crystal in. And then you can either use bobby pins, hairpins, or like a little clothespin to suspend your skewer into your water mixture. So grab all of those things. Again, all the directions will be up on the website and with our YouTube video later this week. But we have to invite our very special guest, Veronica Di Cecco. Welcome back to the show.
Hello, thanks so much for having me.
Her first episode was all about how to identify meteorites and meteorons, and we did a density experiment. So we're gonna try and top it today by doing some sugar crystals. So the first thing that you should be doing right now is you should be boiling your water. okay? I want you to do that right now. Boil your water with your trusted adult, and we'll get to the next step in a second. We are talking about crystals, minerals, and rocks today. I brought a whole bunch of stuff from the museum. You helped me select these objects. So let's start at the beginning, okay?
Yes.
What is a crystal?
So a crystal is something that is made up of repeatable building blocks, kind of like Lego that stacks together. And the structure you see on the outside is representative of the structure that's happening at the microscope level. So something so small that we can't see is happening so many times that it builds this object. And so many types of things form crystals. So that's one that you have there. That's a piece of quartz.
Piece of quartz. Does quartz do anything special?
We use it for a lot of different things. If you melt it down, you can make glass out of it. It also is a very fancy word called piezoelectric, meaning it vibrates energy at a certain frequency, so they use it as a timepiece in watches for that reason.
Whoa, that's awesome. Okay, wow, I'm already learning a lot. We, as a thing that the audience knows, I love dinosaurs and I love space, and rocks and minerals definitely connect to both of those things a lot, but I know like nothing about them, so this is a big day for me to learn. Okay, sorry, again, I think you might have answered this already, but wait, how does a crystal form?
So it's building blocks that stack together over and over and over again to make this structure that we see on the outside. So this can happen if it's something like a mineral, which is what we're going to talk about next, something that can happen in nature, but there are also types of crystals that we can make man-made, like the sugar crystals we're making. So those aren't minerals, they happen because we're making them.
Right. Okay, so what is a mineral?
So a mineral has this really specific definition that is kind of complicated sounding, but it's not that bad.
Let's give it a shot.
It's a naturally occurring, so it means it happens in nature. It's a solid. It has a chemical composition that's the same. So you're holding a piece of mica. That mica has a chemical formula, and we describe all micas using this chemical formula. It has this structure, the same as structures of crystals. It has building blocks that repeat over and again at micro level. But the main things are those. So naturally occurring, inorganic, and repeatable structure, chemical formula to explain it.
So as I learned right before the show, it's mineral is inorganic. So sugar is not a mineral.
Right. So sugar, the sugar we're growing are sugar crystals. It has a crystalline form, but it's not inorganic. It's organic, so it's not a mineral.
Got
and
it.
Also, we're making it, so it's not a mineral.
Got it.
Man-made things aren't minerals.
People can't make minerals. Okay, so what is a rock?
So a rock, I like to use this analogy because everybody knows these things. If you think of minerals as being like the ingredients, like a loaf of bread is made out of wheat and sugar and salt, and all those things those ingredients are the minerals. And then the rock is the product you have at the end. So you bake your minerals to make your rock. So you bake your ingredients to make your loaf of bread. That's the relationship of one is rocks are made up of minerals.
Rocks, oh man, that's great. I love that analogy that bread is made up of things. So rock is made up of minerals.
Right. And so if you look at the rock you have, it's actually a piece of granite, and there's different colors inside of it. So it's pink, it's black, it's got some gray bits in it too.
Yeah.
So those black things are actually a mineral you were holding up before. So you were holding up before a mineral called mica, which is black and platy. And you can actually see some of those black platy speckles inside of that piece of granite. So you can see that it's made up of different things.
That's awesome. Okay, I have a weird question that we did not talk about. So sorry if I'm going to stop you. What is concrete?
Concrete is a man-made material. It's made up of, so my partner is a civil engineer, so if I get this wrong, he's gonna be very mad.
Yeah.
But it's made up of something called aggregates, which are broken up bits of other materials, and it's held together by a cement. And that cement is usually calcium carbonate, which is what seashells are made of.
Oh.
So it's kind of like a rock. It's a man-made kind of rock in a sense.
Got it. Okay, cool. That just came to my mind because I have all these questions because I know nothing about this. Okay,
Very
so
fair.
with that said, we're going to go back to our project and we're going to get our boiling water. We're going to get our boiling water brought over to our table in our household. What we're going to do is we've been boiling the water. We're going to get 1 cup of it, okay? 1 cup of boiling water to make our mix. Now, again, we're working with a really hot substance. Boiling water is dangerous, so you need to be really careful. What ways that I'm trying to be careful today is I have, I'm wearing what is this? I'm wearing this apron.
An apron.
Yeah, nice. Thank you for helping me on that one. And I also have my Mickey Mouse little cooking gloves right here as well. We have our boiling water brought ever so gently, ever so nicely, brought right over to our table. Thank you for that, however that might have happened. We're then
Magic of television.
Yeah, the magic of Instagram Live right in front of you. So now we're gonna put our boiling water, so again, be very safe, into our container. So I'm just gonna like pour. You can really see the steam coming right out of it. I would not suggest doing it on like the edge of a thing. Oh, I'm now learning something new here too, okay? So friends, you really want your the block you use, not the block, the container you use to be a little bit thinner than mine because we're gonna have to put our skewer into it, and so we're only going to be able to make a sugar crystal that is that big, okay? So that's a learning that we learned on our show right here, is you want to use a container that is narrower so that your crystal goes up higher, okay? And so we just learned that right here on the show. Big learn. Now, once your water is inside of your container, you then need to mix in your sugar. Okay, now remember, 3 cups of sugar. And what does that look like? A heck of a lot of candy. All right, so this is not a healthy thing that we are making, but we are trying to, I think the word is saturate our water.
Yep. You want to super saturate.
Super saturate. Okay, now let's keep going with the science a little bit here. What does saturate mean?
It's kind of like you're filling up your liquid with the ingredients you want to build your minerals out of. So you're putting all of these molecules in there. They're going to be floating around in that water, reacting, doing fun things. And then eventually they're going to cool down and come closer together and grow together.
Okay, and then what does super saturate mean?
Basically, you've got so much of it, it's like settling out and you see it like precipitating on the bottom.
So that's
fancy
like
chemistry words.
So maybe you've seen like your parents make coffee or something like that, and you see them put sugar in, and they'll mix in the sugar and it goes into the water. But if you put too much sugar in, then it can no longer mix and you can just see it. And that's what happens when you super saturate something, and that's what we're doing here so that we can make our sugar crystal. So while I put this heck of a lot of sugar into this water mixture, we're going to keep going on with our questions. Okay. Where do we find minerals?
So minerals are found all over the earth. The earth is made up of rocks and minerals. So these minerals make up the rocks. The rocks are everywhere. But some conditions form bigger ones than others. So if things have a lot of time to cool, they cool very slowly. They grow minerals very slowly over long periods of time. They can get really big. But if they cool very quickly, they stay very small.
Okay.
So in things like volcanic environments, if you've got something that's called a vug, which is basically just a pocket of gas or fluid that's trapped and it's like stuck in an egg shape for a long period of time, eventually those will slowly crystallize and form geodes, which you might have seen before, which are pockets of crystals on the inside of rocks.
Oh, okay. So I have an amethyst right here.
Yeah.
Is an amethyst a geode?
So a geode is like one of these pockets. that has been filled with crystals, and when you crack it open, it's filled with crystals on the inside.
Right.
And so basically minerals like to form in little holes and cavities and things that can keep all of these fluids and crystal forming bits together for a longer period of time.
Okay, you said something really interesting about growing. And I think
Yes.
you mean that in like the literal sense.
Yes,
That
they are
minerals
literally
grow.
growing. They're not alive, but they're growing.
And
So it's just like we're going to be doing these sugar crystals going to be growing. So these building blocks are going to be coming together because of the chemical reactions happening, and they're going to be getting bigger and bigger and bigger. So that's called growing in that sense.
that is so cool. So even things that aren't alive can grow. Okay, we have a question from the chat. Why do rocks, or why do minerals that make up the rocks change color over time?
Oh, so some minerals can do that, and they don't always, but they can react with things in our atmosphere. So sometimes you have a rock that's been buried for a long period of time. It's never been in our air. It's always been underneath the ground. And when you expose it to air, suddenly it has new reactions to happen. New things can happen to it that never had a chance to happen before. And so it can change color that way. Or the sun, like UV light coming from the sun, can actually cause minerals to change color.
That's really interesting, because when we're talking about rocks, we're talking about, in minerals, we're talking about things on like, not just in like our lifetime or in the lifetime of several generations, but we're talking in like the hundreds of thousands and millions of years.
Yeah, millions to billions of years some minerals are.
Whoa. Okay. As you can see, as I put my sugar in, my absolute ton of sugar is also raising the water line. So this might actually work out a little bit better than I thought. Okay, why are some minerals rarer than others?
So basically, some formation conditions on Earth are rarer than others. There's lots of places on the Earth where we have sun hitting the surface, and we've got like nice warm temperatures that are like room temperature. There's like areas of the Earth that are very common in terms of formation conditions, and there's some that are much more rare. So it's all related to how rare the Earth occurs. This isn't making any sense.
No, it makes sense. It makes sense. There are locations on Earth where that have more of the different things that make up minerals that allow for that to form, and then other places have less of it. And
all those building blocks need to be in certain places for minerals to form. So those building blocks are usually elements, and those elements only exist in certain places. So there are some Earth conditions that cause mixing and make these things move around, like plate tectonics and magma flowing and eruptions and stuff like that. But if that's not happening, then all these special ingredients stay separate from each other, and so we'll form different things in those places.
Got it. Okay, we're gonna do the next step, and then we're gonna talk about something we talked about in our pre-interview called environmental stewardship, because that's really important. So the fun thing about making your sugar crystal is not only will it taste good because it's literally just sugar, which, as we know, for many kids, that's like what fuels them. It certainly did when I was younger, and now it just, looking at the sugar is making me physically ill. This is so much sugar. Okay, so fun things you can do with this in this mixture is you can put in some food coloring. So I have green. I'm just gonna pour some of that green food coloring right in. I'm gonna do a couple drops. You can see it start to change. There's a lot of sugar, so I'm gonna put a lot of green. All right. The other thing that you can do, and hey, we need to buy new green food coloring. The next thing is you can add in a flavor. So that can be like, this is like almond extract, so you can use that, like if that's safe in your household. You can use vanilla, whatever you want. So I'm just gonna pour a little bit of that in there. Give it that bonus boost of taste. That seemed like a lot. I don't know, I'm not a cook. And next thing I'm gonna do is I'm gonna start mixing this all together. And you can see the different layers of it. You can see just how much sugar there is in there. You can see as the green tries to mix in. Again, this is super saturated, so there's so much sugar here that will actually be able to grow a crystal. Okay, so while I mix this together, rocks, minerals, all these things, they come from the ground. We use them for a variety of things, which we'll talk about in a second. But we have to do that safely and responsibly, right?
Right. So everything in our daily lives, everything that's around us, if we can't grow it, we have to mine it. It's just the nature of our world. And there are responsible ways to mine and responsible ways to look after the environment that's around us. And there are poor ways of doing it. There are ways that cause damage, ways that are really bad for the environment and bad for the peoples who live in these environments. So everything we do has to be done safely and responsibly. And so that is very important in the realm of mining, because all of these things, we need them in our daily lives.
We've sort of built a society that requires a lot of these things, but we have to do it in a way that protects the people that the land that live on land. We have to protect our waterways, and it's the same way with like logging too. There are ways for us to like responsibly log, but a bad way of logging or cutting up trees is just clear cutting entire rainforests. That is bad for our biodiversity, that's bad for people, that's bad for water, that's bad for our society. So we need to find ways to do it safely, respectfully, thoughtfully, and responsibly to us and to our world. Okay, so that's a very, very important thing, and that's all a part of environmental stewardship, of being able to live with our planet and to grow not only like our values, but also our planet as well. We got to do these things safe, okay? So you're gonna let this your thing just sort of settle, like hit 10 minutes on this, okay? As it starts to cool down. The next thing you're gonna do after that, though, is you've mixed everything in, is you're gonna take your little skewer and you're gonna mix it on more sugar on your plate, okay? So we're gonna add more sugar to this experiment, and that sort of like helps seed our little experiment for later. You see how, it sort of like covers the stick like that, the skewer? Does all the sugar need to dissolve? No. Great question. We are creating a super saturated environment when there is so much more sugar than the water can take on, so that we can effectively make crystals. So I really like that question, okay? As you can see in ours, the entire bottom is full of sugar, and then as well, that water level there too is also full of sugar. Great question, friends, in the chat. And so again, just cover your stick in sugar. Love it, like it. Some dropped. I'm gonna have to vacuum after this. Okay.
And you used a seed that's really good, because you actually have to make that seed for the crystals to grow off of.
Lots of new words today, we learned, and words that we know, but put into a new setting, such as like growing and seeds. Okay, so the next thing I want to talk about is sort of ways that like all of these things are used. And one of the ways is from a word that I know as a gem.
Yeah.
What is a gem?
So gems are crystals that we have cut or polished into some form of adornment or jewelry. So I think you're holding up a piece of turquoise there. And so turquoise is a mineral. In this piece, it's been cut so that it has a shape to it, because in nature it doesn't look like that. It's got a different shape. And when we cut it, then we call it a gem.
That's awesome. And so we know that rocks and minerals and all of these things are turned into a lot of jewelry. We're going to show off some jewelry now as well. Why, like this, I guess this is a history question, so I don't know if you're going to be able to hit this, but like, what is it about these things that make us so excited to wear them?
I think part of it, so again, like I'm a scientist, I don't know fully the anthropological explanation behind all of it, but part of it is people like sparkly things. I mean, why not? It looks absolutely gorgeous. One of the reasons why I love gems and minerals and rocks is because it forms on its own. This is something that came out of the ground in nature. Nature produced this. We kind of sparkle it up, polish it, give it a little shine to bring out its qualities. But it is a treasure that you find. It's like finding buried treasure, or buying a piece of treasure, or giving someone a piece of treasure. There's something nice about that people enjoy.
Yeah, I mean, I like this. That looks good. I really like that.
What you got?
Look at that. Look at that engagement ring.
Oh yeah, that is a very nice ring. Very nice.
That's a winner right there. I like that. It certainly speaks to me. I think it certainly speaks in this household. Okay, so, just as people, we love them. I think there's also a little bit of like that rarity to it too, right? Or the perceived rarity. There's not a lot of it, so being able to wear it feels special. Minerals and rocks are used not only in our jewelry, but they're used in another form of fashion as well, which is makeup. What's going on with that?
So earlier you were holding up a mineral called mica. It's a group of minerals. It has thin plates. It was black. Yeah. And if you look really closely at those plates, they're kind of sparkly on certain angles. And they're very fine, so they break up quite easily. It's very soft. And we actually use that in makeup to make the sparkliness in eyeshadow or that little bit of sparkle. And it's a very natural way of doing it. It doesn't require chemicals to produce that. And it breaks down. So yeah.
So when you wear
that little healthy glow you had at the beginning there from your makeup touch-up.
Yeah. Okay. So wait, what is this called again? Eyeshadow?
The mineral is called mica. Or the mineral group is called mica. One of the ones, when it's black or dark brown, we call it biotite.
Am I applying
and minerals
this
always end in "ite" at the end of them, usually.
Sweet. That's cool. I didn't even think of that. That minerals are used in makeup. That's so interesting.
Just to throw it out, minerals are used in almost everything we use in our daily lives. So your cell phones, your cars, pencil lead, anything that we can't grow, we have to produce from minerals or from working with those minerals to produce different types of materials.
Okay, so that's a really big thing, folks. Like the cell phones that you're watching this on and the computers, they use minerals. So it's
lots of them.
It's not just in our jewelry or in our makeup, but it's in the things that make our lives happen. So that's a really important thing. Okay, I'm gonna go put this our sugar crystal in. I'm gonna do the final step here. Okay, so you can use a bobby pin or a hairpin, but I'm going to use a clothespin. All right. And I'm going to put my clothespin right into the middle of it. I'm then going to bring this down right on into it and right in the center. I don't want it dangling. I don't want it lying against the side. I want it to attract as much sugar as it can. So remember, you seeded your stick first by covering it with water and then rolling it in the sugar. You then put it directly into the middle of your sugar solution right here, okay, which again is a ton of sugar. It's 3 cups of sugar in 1 cup of boiling water. You're then gonna go put this aside, okay, somewhere where you're not gonna touch it, where you're not going to bump it, where it can be still and safe, and you're gonna forget about it for a week, all right, 7 days. I know it's going to be enticing because you're look at that sugar in that water. I want to consume it right now. It will be better in 1 week. How much better will it be? It will look like this. All right. Look at that. Look at that sugar stick right there. Okay. So that's something that you can make. Put it away. Okay. 2 questions and then we're done. 2 questions, then we're done. Okay. Minerals are also used in things that help us create renewable energy, right?
Right. So many different things like batteries. Batteries they have lots of different types of minerals in them that will store energy so that we can reuse the energy that was created earlier. But everything that we take out of the ground, it has an amount of time that it takes for it to rebuild again. So we're growing sugar crystals. These sugar crystals take time to grow. Everything that we have that we mine, that also takes time to grow. So the more renewable energy sources we have, the more renewable materials we have, the better. And minerals can help us make that happen more easily. So if you are collecting solar power, you need somewhere to store it for when the sun isn't shining as strongly or when it's a cloudy day. So there's different types of minerals to do that. Usually we've been using lithium-ion batteries that uses lithium-based minerals. A lot of these things are actually types of salts that can come from different desert areas where we're drying it out and we're extracting those lithium salts.
Wow, minerals are used in so many things, and again, we have to do so thoughtfully, and we're going to keep doing it better and better and better. Okay, now we've sort of alluded, skewer can't touch the bottom of the jar. It will get stuck. Oh, that's a great job, chat. because the sugar is going to start to solidify, you don't want it to touch the bottom of the jar. All right, and so now we've accomplished that. Great job, friends. I think we're there. There we go, okay? See, if we do this together, we can do it a lot better. All right, we've sort of been explaining the science of this as we've been going along, but my final question to you is, what is happening in this jar?
Okay, so you've got a bunch of these molecules of sugar floating around. They've been dissolved in this water. And as the water evaporates, those molecules are going to come closer together and they're going to start to attach to each other and grow together. But we needed to give them a place to grow off of, because otherwise they would just start growing on the bottom. And this is called a nucleation point. So we've seen fancy science word. Nucleation is what's happening. They're nucleated on those sugar crystals that you put on the skewer in the beginning. And so those sugar bits that you dissolved at the beginning, those are the building blocks that are coming together, like those Lego bricks that form the overall structure. So whenever it's fully formed, the outside structure that we see of all those little crystals are basically the same thing that's happening on the inside at a very tiny microscope level. So even though it's not a mineral, it's behaving like a crystal. It has a crystalline structure.
There you go. I really like that. We learned a lot today on the ROMKids Show. Wait, was that last word nucleation?
Yes.
That's your $10 word take home with you today.
Fancy thought also, extrapolating, if you drink pop out of a plastic cup, all of the bubbles get stuck to the side. And this is because a plastic cup is rough, and so all the bubbles can nucleate on the side. So don't drink pop out of a plastic cup. It'll be more flat.
Whoa! That's awesome. Okay, sorry, we do have a question from the chat before we wrap up.
Okay.
Steel. Are minerals used to make steel?
So steel is, I always get the metals wrong. Mm-hmm. One of them is iron. I want to say nickel. I do this a lot. But so steel is actually two different types of elements mixed together to form a stronger metal. And so material science is the study of taking things like minerals and taking materials, working with them and looking at their properties and turning them into useful things for everyday life. So that's how we've created steel, is mixing together these materials.
There you go. Much like how rocks are mixed together minerals together, right? That was my big learn today. That rocks are just have a bunch of different minerals in them, and that's how you get them. Okay, I really hope your sugar crystal experiment is fun and tasty. Please take your time eating it and brush your teeth after it as well. It is so much sugar. Next week is April break here in Ontario, at least. So we're gonna not do an episode next week. The following week, we're gonna do an episode all about masks. Our friend Famita Suleiman is coming to join us. We had a really great talk last week, and we were really excited to talk to you about a future mask exhibit coming to the museum, the power of masks, as well as we're going to sort of design our own, because a lot of art is being featured on masks these days. So we'll see you on that in 2 weeks. Veronica, thank you for coming back to the show. This was so special. Thank you for your time.
Thanks so much for having me. I'm jealous I don't have any sugar to eat. I have to go make one too.
There we go. Okay. Thanks, everyone. We'll see you on YouTube. Bye, friends. Wear a mask. We love you. Stay safe. Bye, everyone.